So today we are going to discuss about the most important and most interesting topic of the engineering, which has very large applications, differential equation. The term differential equation comes many way in many engineering problems. When it comes in engineering problems, the problem comes that how we have to solve. So we must have the basic knowledge of differential equation, its type, its order, its degree, and basic methods which involve in the solution of differential equation. The very basic definition of differential equation is that suppose we have an equation which contain a unknown function which we have to determine from the equation, and suppose that equation contain that unknown function and also its derivative, then we say that it is a differential equation. But the basic classification of differential equation is that the unknown function which we are going to determine from the equation, if it is of one independent variable, then we say it is ordinary differential equation because it involves ordinary derivatives. But if we talk about the unknown function which have more than one independent variable, then we call it as partial differential equation, which comes in many problems. So basically there are in the starting two classification, one is ordinary differential equation and another is partial differential equation. So basic definition which I have given is that we have an equation which contain a unknown function and its derivative which we have to determine from the equation. So we say it is ordinary when unknown function having only one independent variable. If unknown function having more than one independent variable, it is called partial differential equation. In our nature, in our various engineering models, engineering problems, there are many situations when we get differential equation. Then we see as if it is ordinary partial differential equation or partial, then we solve according to that. So today we are going to discussion about the ordinary differential equation of higher order. If we describe ordinary differential equation, then we say a equation which involve the unknown function and its ordinary derivatives. The unknown function which we are going to derive from the equation. So if we are talking about the ordinary partial differential equation, we are talking about the unknown function which we are going to determine. It is a single variable independent variable function we are going to determine. Now, what are its further classification? So its classification is simple, that we are saying that it is a ordinary differential equation and partial differential equation. Then further, what are further classification? We are saying that what is the order and what is the degree of differential equation. So if we are talking about differential equation, as I told earlier, an equation involving the dependent variable, independent variable, and the differential coefficient of dependent variable with respect to independent variable is known as a differential equation. There are some examples: dy dx equal to cot x, d2 by dx2 plus y equals to 0. If we see this equation, what we are going to determine from this equation, that is y, and y is a function of x. So y is a function of single independent variable. So we are saying that it is an ordinary differential equation. So here equation involves first order derivative of unknown function and a function of x. In equation 2, d2 by dx2 plus y equals to 0. So here we have an equation of an unknown function having one independent variable which involve a derivatives of higher order 2 and unknown function y, which we are going to determine from the equation. Add see example number 3 and example number 4. Example number 4 is x del z del x plus y del z del y equals to 0. So in example number 4, we have a dependent variable having more than one independent variable x and y. Here z is a function of x and y. So delta z and delta y both are derivatives of z with respect to x and y. But here they are the partial derivatives of z with respect to x and with respect to y. So we will say about equation number 4 that it is a partial differential equation. So all four examples are here, 1, 2, 3, and 4, out of which 1, 2, 3 are the examples of ordinary differential equation, and example 4 is the example of partial differential equation. So as we see from four equations that we have a equation present here, we are finding that unknown function from these equations by particular method of solutions of differential equation. Now, what are the further classifications? So we till now we have two types of differential equation. If we write differential equation, then we have two types of differential equation. One is ordinary differential equation and another one is partial differential equation. So these are the definitions of ordinary and partially, which we have defined according to unknown function. As we can see, ordinary differential equation is a differential equation which involves only one independent variable is called an ordinary differential equation, and a differential equation which involves two or more independent variable and partial derivatives with them is called partial differential equation. So as seen above, equation number 4 is a example of partial differential equation. So these are the very basic classification of differential equation. If we say only the word differential equation, then we are talking about whether it can be ordinary or it can be partial. Now, what are the further classification of an ordinary differential equation? There are two basic classifications of ordinary differential equation: order and degree. How we define the order of an ordinary differential equation and degree of an ordinary differential equation. So here in example number 1, we are doing equation number 1, dy dx equal to cot x. So it is a example of ordinary differential equation, and the highest order derivative which is occurring in equation 1 is dy dx, whose order is 1. So we will say that it is a first order ordinary differential equation. In equation number 2, the highest order derivative occurring here is d2 by dx2. So here we will say that it is a second order differential equation. Since here the highest order derivative occurring is d2 by dx2, which order is 2. Now the another terms which comes with degree is degree of differential equation is what is the degree. If we check here that what is the highest order derivative present in the equation. Then another thing we are going to check is what is the degree of the highest order derivative that are present in the differential equation. So if we check again equation number 1, dy dx equal to cot x. So here the highest order is 1. But dy dx, the order is 1, but if we check the degree, then we must check the power of dy dx. So here dy dx power is 1, so we will say that degree of equation 1 is 1. As in equation number 2, the highest order derivative is d2 by dx2, and here the power of d2 by dx2 is 1. So we will say that it is an ordinary differential equation of order 2 and degree 1. Now if we check in equation number 3, y equal to x dy dx plus dy dx का whole cube. So here highest order derivative is dy dx, which is occurring 2 times in equation. First time is multiplied by x and plus second times dy dx का whole cube. Then dy dx का whole cube means here the power of highest order derivative is 3. So the degree of equation 3 is 3. So these are the basic starting classification of any differential equation. When we define a differential equation, what will we say? That it is a first order second degree differential equation. So we start with the order and degree of the differential equation. Then we nominate differential equation by their order and degree. So starting from the order and degree, now if we are checking the order, then we are saying that it must be the highest order derivative present in the equation. But when we check the degree of the differential equation, there are some conditions with the differential equation. That differential equation must be free of radical signs. So here if we say that d2 by dx2 plus under root 1 plus dy dx का whole cube equals to 0. This is a differential equation. And if we have to find its order and degree, then the condition with the degree of the differential equation is that the differential equation must be free of radical signs. Here radical signs which means the sign of square root, the sign of cube root, or any radical powers of which present in the equation. So first we try to remove this square root from the equation. For this, here we have taken this term to the right hand side of the equation. d2 by dx2 equals to minus under root 1 plus dy dx का whole cube. Now for order, if I see only order, then here clearly the highest order derivative term present in the equation is d2 by dx2. So here order is 2. But if I have to check the degree, then first of all, here it is clear that degree of d2 by dx2 is 1. But the condition which is mandatory for the degree of an equation is that it must be free of radical sign. So for finding the degree of the differential equation, we must square both sides. So for squaring both sides, here we get d2 by dx2 का whole square equal to 1 plus dy dx का whole cube. So here we have a differential equation which is free from the radical sign, d2 by dx2 whole square minus dy dx whole cube minus 1 equals to 0. Now it is free from the radical sign, so we can define its order and degree. So here highest order derivative is d2 by dx2 and its power is 2. So we will say it is a second order, second degree ordinary differential equation. So order and degree classification of differential equations is very basic thing in differential equation. We must be familiar with the order and degree. So again, I repeat my things that for order, what we are going to check, we are going to check the highest order derivative present in the equation, and for degree, we check the degree of that higher order derivative. But what is condition? Condition is that our equation must be free from the radical signs. Radical signs means there should not be any term power should be just like 1 upon 3 and 3 by 2. So what we will do for degree, we first make that equation free from that radical terms. So we now check some order and degree of the another differential equations. So here equation is that d cube y dx cube whole square minus dy dx whole power 5 minus 1 equals to 0. So we have to find the order and degree. Now, what is the highest order derivative present in the differential equation? That is d cube by dx cube. So its order must be 3. Now we are seeing that another derivatives are also present. But for order, we will check the order of highest order derivative present in the equation. So d cube by dx cube and dy dx, there may be another terms of derivatives. But out of these derivatives, we will focus only on highest order derivative which are present in the differential equation. So that is here d cube by dx cube. So order is 3. Now degree. So for degree, we check the power of that highest order derivative. So here d cube by dx cube की whole power 2. It means here degree is 2. Now we see below it's another example of radical terms. So here what is differential equation written? It is that d cube by dx cube whole power 5 by 2 equal to dy dx whole power 5. Now here not any square root sign, not any cube root sign, not any square root or cube root like any symbol is present here. But if we defined radical sign or radical degree, means the degree must be of the type 1 upon 3, 3 upon 2. So here what is written here? D cube by dx cube की whole power 5 by 2. So for degree, we have to make it ag 5 by 2. Now we convert it into simpler terms by squaring both sides. If we square both sides, then d cube by dx cube whole power 5 by 2 becomes d cube by dx cube whole power 5. And on the right hand side, dy dx whole power 10. So again, if we taking order, the highest order derivative is d cube by dx cube. So order is 3, and degree, the power of d cube by dx cube is 5. So here degree is 5. So it was the example of radical sign, radical terms which we are seeing in the equation. So suppose here if any terms comes, suppose here comes 1 upon 3, d cube by dx cube whole power 1 upon 3. Then we will cube on both sides. So we will eliminate the denominator terms of that radical power. According to that term, we will square, we will cube, we will take any type of calculation according to that power. Now we have defined that a ordinary differential equation, that it is a particular order and particular degree differential equation. So we will, if we introduce any differential equation, what we introduce, we will say it is a first order differential equation and second degree differential equation. So order and degree both are associated with the differential equation. Now the solution, what is the solution of that differential equation? What is the meaning of solution? As we define the differential equation, that it is an equation containing unknown function and its derivative. So here the solution means we have to define that unknown function. So according to this definition, suppose d2y dx2 plus y equals to 0. Then what is unknown here? Y. It means we have to find the solution, we have to find the y. For there are some methods, but if we saying solution, then we will say complete solution. So what is general solution? The general solution of a differential equation is the solution in which the number of arbitrary constant is equal to the order of the differential equation. For example, d2y dx2 plus y equals to 0. It is of second order differential equation and its solution is y equal to c1 cos x plus c2 sin x. We can easily check out that this must satisfy this equation. Now C1 and C2. What are C1, C2? They are arbitrary constant. It means we can assign any value to these constants C1, C2. And here the order of the differential equation is 2. So we are using two arbitrary constants C1 and C2 in this solution. So we will define that it is a general solution. And C1, C2 take any value which we can assign because it is called a arbitrary constant. Now, what is particular solution? Then a particular solution of a differential equation is the solution which is obtained from its general solution by giving particular values to the arbitrary constant. If we are defining in the solution that y equal to c1 cos x plus c2 sin x, then we are saying that it is a general solution. But as I said, c1, c2 are arbitrary constant. So if I assign c1 value 1 and c2 value -1, then we have a particular solution according to particular value of c1 and c2. We are taking c1 1 and c2 -1. Then our solutions become y equal to e की power x minus e की power minus x. So if we take particular value of that particular arbitrary constant, we are saying it is particular solution. And if we are writing only arbitrary constant, then we are saying that it is a general solution of differential equation. But here one condition is mentioned, that number of arbitrary constant must be equal to order of differential equation. So if it is a second order differential equation, there must be two arbitrary constant present in the solution. Now we defining the ordinary differential equation with the terms of order and degree. Then further, what is classification of differential equation? We are classifying according to linear and non-linear differential equation. In many models, we come across the linear differential equation. Now, linear differential equation comes with two categories: linear differential equation with constant coefficient and linear differential equation with variable coefficient. So here equation number 1 represent a general linear differential equation. It is a particular form. The term linear means the degree of the differential equation must be 1. Now according to this definition, the equation 1 written here is a naught dny dxn plus a1. Then what is the order of derivative? N minus 1 plus a2. Then order of derivative is n minus 2. It means we have orders of any order, derivatives of any order, but degree must be 1. So here what is the order? N. But highest order derivative dn y dxn having degree 1. So we are saying that it is a linear differential equation. Now with constant coefficient, meaning the meaning of constant coefficient is that all the coefficients present here, a0, a1, a2 up to an, they all are constant, and the right hand side where qx is written, that q must be a function of x alone or q may be constant. Then we will say that it is a equation of nth order linear differential equation with constant coefficient. So constant coefficient means all derivatives are present with the constant coefficient a0, a1, a2 up to an, all are constant. If a1, a0, a2 up to an, one of the coefficients become function of x or any function of x, then we will say it is a linear differential equation with variable coefficient. But a0, a1, a2 up to an must be either function of x or must be constant. Then it will be a linear differential equation. It may be with constant coefficient or it may be with variable coefficient. Now, suppose a1, a2, an or any one of the coefficient becomes y, then it will become non-linear. So for non-linearity, if we define non-linearity, we are here defining linear, that what is linear. If we defined what is non-linear, conditions for non-linear, we will say that the highest order derivative and other terms, all degree are more than 1. It may be more than 1, any order derivative. So if its degree is adjacent to 1 alag, then we will say that it is a non-linear, or it must be, we will say that if there is a product of various order derivatives, or we will say that there is a product of dependent variable with the various order derivatives, then it will become non-linear. So for non-linearity, the degree must, sorry, for linearity, the degree must be 1. For linearity, there should not be any product of various order derivatives. There should not be any product of dependent variables with the any order derivatives. So if we see these three conditions in particular equation, we can easily define that it is a linear or non-linear. So for linear differential equation, this is the particular form which equation 1. We compare the equation with the given equation number 1. Then we define that it is a linear differential equation. If we are taking with variable coefficient or with constant coefficient. So there are different solution methods for the linear differential equation with constant coefficient and linear differential equation with variable coefficient. Linear differential equation with constant coefficient, its solution contains two parts. One is CF and one is PI. The CF is called complementary function. For complementary function, we are solving this f dy equals to q. Only we are solving left hand side. F dy equals to 0. And for pi, we are solving taking only q function. So these are the two parts of the complete solution of any linear differential equation with constant coefficient. Okay.